Okay, in a set of 52 card decks, you are taking two cards. Okay, either you take first card and then second card, or you take the first card, you put back, and then you take the second card. Okay. In both case, the probability of having the black ace in the second card, the same or not, the probability. Okay, think about it. Is it the same or not? Alright. Hi, my name is Dr. Kai. In this third part of the probability, you'll be able to distinguish or to calculate the probability of independent events to occur. So let us know another concept of probability, which is a conditional probability. That means the probability to have something given a condition before. So you are given the conditions and then you have to calculate the probability. Alright, so this conditional probability can be written as the probability of A conditional that B occur. Okay, that means the B must occur first, then what is the probability of A? Okay, we can say like that. So the probability of the of this situation can be visually represented by this Venn diagram in the sample space. So you have B, and then A that occur with condition of B is represented by the intersection of A intersect by B. So this area. So this area, it is the thing, the event occur in the events of B. Okay, so that is the interpretation of this conditional probability. So that is the number of outcome of A intersect by B. So how many elements in this area, divide by the number of outcome in B. That means number of element in A intersect B divide by the number of element in B totally. So that we can actually modify a little bit by calculate the number of outcome in this area divide by the element in sample space divide by the number of outcome in B divide by the sample space. So that means actually we don't it will give you the number of 1, the result of 1. But the why we do that, because we want to calculate the number of outcome over the element in S, so that we can write it down as the probability of A intersect by B divide by, so this one is the probability of A intersect by B, and this one is the intersection of B, the outcome in B over the number of outcomes in S. Okay, so this is, we will use it in the next slides because it is very important, this relation. Okay, now let's introduce to the independent events. What is the what are the independent events? So two events are independent if the occurrence of either event, that means either A or B, has no effect on each other. Okay, so let to say is A and B are independent only if A and B are independent only if conditional given A, B occur is equal to the probability of B. Okay, or in either way round. Okay, that is the event of A intersect by B is equal to the multiplication of B in the event of A and the probability of B to occur. Because from the previous slide, okay, from the previous slide, you see it's here like this. So PA given B must be independent if P this is equal to PA. We can say this PA, right? So this must be independent. So this is PA dah multiply by PB. You see by PB, then you left this. So this is rearrangement of this. Okay, therefore, independent, this is some misspell. Independent result generalized for an independent event. So if we have many events more than two, okay, so the probability of those events occur is the intersection of those events, as many as you have, is equal to the multiplication of that event to occur. Okay, so let's look to the. Okay, for example, two cards are chosen at random from a pack of 52. So determine the probability of an ace in the second card with the condition the first card is also ace. Okay, so for this, let's define the event A as a first card is an ace and B is second card is also an ace. Alright, so the probability for the first card is ace is 4/52 because this ace. Okay, so 4 cards are ace in a deck. So 4/52, then you have over 13. Okay, and then we calculate the second card is also ace, which the condition the first one is also ace. So what will be? It's still 4/52 because when we take the first card and then we put it back, then we take a second card. So that means the probability is just the same, 4/52. So the probability of B of a second card is ace, which condition the first card is ace, is just the same. The probability is the value the same. So the uh the 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 event B and event A is independent. Okay, they does not, if does whatever happened in A doesn't affect whatever happened in B. This is what it meant, independent events. Okay, but if we take the first one and then put it out, so the card remain 51 only. So that's why we have here 51 only. Okay, 51 only. And then the if the first one is ace, that means we remain another 3. Okay, so that we have 3/51, and it is no longer same as the 1/13. So it depends on the first condition. That means it depends on the event. So when the probability is not the same, so it is not independent event. So it depends on the first condition. Okay, next we go to the total probability. Okay, suppose that we have the sample space here. We have an event B and also A1 and A2. Okay, B is partition, so we partition it into the intersect with A1 and the one area intersect with A2. So the probability of B here actually is just this, the probability of B intersect with A1, so this area. Okay, let's make some color. Okay, so this one is A1 intersect B. Okay, so here, and then let's color for green, B A2, B intersect with A2. So this probability. So the probability of B is probability of this area plus this area. So we can see immediately. Okay, the law of total probability for mutually exclusive event A and B. So A and B are exclusive because there is no intersection between A and B. So B is we can say here A, right, equal to B. No, so we cannot say that. Okay, so it is just exclusive. It cannot happen simultaneous, we can say. That these two event A and B cannot happen in one time. Alright, so the probability of B is equal to the probability of B in condition A occur. Okay, because you can say, so this is this is all the area of A1. Okay, so this is area of A1. So if A1 occur, so the condition of B occur when E1 is the condition, multiply by PA1 plus PBA yang this one. Okay, the multiple by the probability of A1. Okay, that is the condition for n mutually exclusive. If we have more than two, this is two event only, right? A and B. But if we have more A, so you can make a summation of the probability product between these two probabilities. Alright. So let's have an example. A box contains 8 red and 13 black components. A machine draws components at a random from the box and it fits them into a circuit. What is the probability that the second component is red? Okay, so let's say the first component red is A1. So this is the first component red. Okay, the first component black. Okay, B is the second component. Okay, second component B. Alright. So we want draw component at random from the what is the second component of red? So we want to calculate this one. Okay, this one. Where it is B condition A1. Okay. So that is what we want to calculate here. So we have this and this. Okay, so the probability of the component is red. This one lah, all this red. This red. Okay, that's mean the probability of B. So when we make the first component is red is 8 over 20. The component of 2 is 13 over 21. Because why 21? Because 8 plus 13 is 21 possibility. So the probability of B when condition A1 is 7 over 20. And then the condition of taking second is red is 8 over 20. Okay. So the difference is 7 and 8 because 7 if the first one is also red, so we lost one red. But if we have this B red and also the first one is not red, so the ball remain 8. So that's why we got it 8. Okay, so by putting the relationship of the total probability here, we can get the probability of the second component is red is 8 over 21. Okay, so that is in the case if we take the first one and we don't put it back. But if we take the first ball and then we put it back, right? So we have to consider that the red number, the red ball remain the same 8. Okay, so that is the change, and also the total number also still 21. It doesn't change, so it still remain 21. The calculation is 8 over 21. Okay, when you compare 8 and 8 and here is 821, you see it is same, right? It's same as a it's same as the PA1. So that means we can say both are independent event. It doesn't depends on the A1. Okay. This is also the same. So that means it is also does not depend on the condition. So they are independent events. So we can conclude like that. Okay, so finally, these are the summary of what we have learned from this topic. So take care of this either mutually or not mutually exclusive. There are the difference there, additional of this term, and then for the not independent events. Okay, sorry, this is not in this is type it is for an independent event. The probability of those independent event is the product of those probability. And lastly, for n mutually exclusive event, so the total probability can be written with this relation. All right, so when we return back to our teaser, so the this it does matter whether we put it or not. Okay, so it will give you the different probability, okay, due to the independent or not independent nature of the event. All right, so we will go further for the next subtopic about more probability later. Okay, see you then, bye.